Welcome back to Triggy the Love Triangle. My name is Chloe Garcia, student number 222570361. I'm just going to run down some of the more advanced features that I've added into Triggy the Love Triangle to make the experience a bit more user-friendly. The first thing, I guess, is the text boxes. If you push letters, you don't want anything to be added. If you push numbers in angles that are greater than 180 degrees, you want it to warn you with a visual. If it's less than that, it comes out alright. If you push the decimal point more than once, nothing happens. It warns you if you type the wrong number. It also grays out the text boxes that are calculated, and it keeps the text boxes black that are used in the equation. Depending on which one you select, if you want to use these three in the equation, then you just select these three, and then you can type in whatever side value, and then you know straight away based on the color which items are going to be used in the equation. So one of the things I've added into the new version is operators into my length and also the angle class, which I use in the get angle and get side functions. This allows me to multiply sides together without needing to call value. It just makes the equations a bit neater. Of course, when you add operators, you don't just add one or two, you generally try and add all of them. So I've got divide, multiply, minus and plus, greater than or equals to, less than or equal to, greater than, less than, not equal to, and equal to, as well as the compare to and equality checkers, using the iEquitable and iComparable interfaces, which I needed to implement in order to access these override methods. But this allows me to properly implement my operators for as many circumstances as possible, including comparisons between two length objects, a length and a double value on the right hand side, and a double and a length on the right hand side. So that way it doesn't matter what order you put these things in, these operators should still function the same. Another place I've used the operators is in my name triangle function. This is just a small function that describes the triangle depending on the value of the angle and the sides. I'm also using hash sets, which eliminates repeat values, and a string builder that allows me to concatenate different strings without using too many resources. I've got the angle is greater than 90 degrees is obtuse, and the angle is equal to 90 equals right. That way I don't have to go dot value, dot degrees, sorry. I can just use the angle as a standalone double value when comparing against other doubles. And then I can also determine whether or not, based on the hash set, whether or not you've got all sides are the same, which means it's equilateral, two sides are the same, which is isosceles, or all three sides are different, which is a scalene. And then that allows you to, when you enter the info in here, it tells you whether it's obtuse and isosceles, or if it's, maybe this angle is 85, then it becomes acute and scalene. Another function that I've got in this program is the ability to scale the main window. If you want it to be bigger or smaller, you also want the triangle to adjust its own size and shape, or the shape stays the same but the scale updates to suit the size of the window. And this works for any triangle. In order to do this, I also had to calculate the alternate triangle, which you can see shaded in darker, or if I make it bigger, then you can see it shaded here. That the alternate triangle is always a right angle, and it basically calculates the additional width required to get the full width of the triangle. Because if this is 90 degrees or less than 90 degrees, the length of this side is the width of the triangle. But if this is more than 90 degrees, then the length of the triangle is greater than that side alone, and I need to also calculate that side to add them together to get the full width of the triangle. And that allows me to scale that whole width based on the form size and not just that width. Another thing that I'm using in this one is extension methods. This allows me to create functions that appear as though they're accessible from within other objects. So if I've got, I'm using the keyword this text box, and that means that when I use text boxes, I can actually refer to double as a property of a text box. So when I've got text box vertex dot to double, it comes up in my IntelliSense as an extension function, and then it says here extension returns text box value as double, and that way I can actually return the text box value as a double value rather than having to do checks and comparisons every time I do that. I can add an extension method, and that makes returning the successful conversion or unsuccessful conversion much faster. I have also used static functions in some of these classes because sometimes the instance function needs a static function in order to work more efficiently. Now, in the case of the solving triangles, the solve function for two sides and an angle is very dependent on the information being applied in the correct order. So you have to be able to assign a completed opposing pair, an incomplete opposing pair, and an empty opposing pair to this function to successfully calculate the result. But none of these items actually use any instance data. So I can make that a static function, and then I can call that from the instance method. The instance method starts off with 3 opposing pairs, all null, and then depending on the individual properties of each opposing pair, it determines which one is incomplete, which one is empty, and which one is complete. And that way you need the instance method to determine the order, and then at the end of working all that out, then you can use the static method to perform the calculation. And that's how static methods, when used in conjunction with instance methods, can be quite effective. As another more advanced feature, I've added save and load button. That way you can type in values, get triangle, hit save, and it saves those values to text file in the order of priority. So it has angle A, side C, and angle B as the primary items, and then the ones that are calculated, side A, angle C, and side B, they're those ones there. And if you restart the program, you can easily load that data. I could have saved it to a file name and allowed you to choose the file name. That will be something that I might add later again. I've used the file info wrapper class, which gives you access to properties, allowing you to confirm if the file exists or create, and also I've also used the stream writer, which allows you to commit string data to a line in a file, and combining the use of these two, I can get the file name, write the text box data to the file, refresh the file, check if it exists, and then use a process using the file or using the Explorer as the main program, the argument as the file info, and then start it, and that's why it runs the text file in Notepad. I've also got a read function, and that reads the file into the text boxes. Also using the stream reader, which does similar thing but opposite. It reads the text file until the end, gets the line, gets each line, checks if the line is empty, checks if it contains a comma, and if the line contains a comma, then it adds it to the list. I've also used regular expressions, or regex, which allows me to group the string specifically into a string on the left of the comma and a number with or without a decimal place on the right of the comma, and that way I don't have to also convert that string to a number later. The regex does that all for me. And then I'll loop through each line in the text file, convert it to a regex match. If it finds multiple groups or multiple successful matches, then that indicates that it found both a string and a numerical value, and then it uses that information like an array to determine what was the text box and what was the value that goes into the text box, and then it assigns each text box back into the order, so the order that you save it in is the order that it loads it in, and that way, even if I set these ones over there, if I load it, then you'll notice these ones are still the default options because they were the ones that were saved in that order when I saved it. Although this is looking pretty complete as it is, there's always more things that you can add to a program. Sometimes when solving triangles, there's more than one triangle that can be derived from input data. Unfortunately, I've only got it drawing, if it finds one result, it draws that. It doesn't check for multiple results, but I would like to update it in the future to, if it has multiple triangles that can be derived from triangle data, then I would like to show both of the triangles if possible. Also maybe having the ability to save and load to a specific file name rather than forcing the file name. Also, in the case of invalid data, if I type in 140 and 40 or 400, if I hit solve, it says the two angles cannot be greater than 180 degrees, and then it draws nothing, but I could potentially show what it would look like if you had one at 140 and one at 40, and then the lines would not intersect, and then you could visually see why the data was invalid rather than just warning and not showing anything. I wouldn't mind being able to actually show it as well. Finally, just a quick look at the extra attention to detail that I can put into programs by creating an icon and button images. You can see how I've created the icon using PaintShop Pro. I've got layers that I can turn on. I've got separate layers so that the heart comes through the triangle so it looks layered, shadows, etc. And then I've also got the icon editor, which converts that image into a multi-format icon, and that's how I get that to display in the corner. Thanks for watching.